Alrighty, AOB. Okay, that should be the easy one, right? Since I'm starting at A. So it looks like the measure there is 35 degrees. What do we call smaller angles like that? Acute. If you can't remember it, you can remember, oh, that's a cute little angle. Get it? Acute? All right. So that's 35 degrees. Okay, let's come down here, and this is acute. Okay? Acute, they can get as big as what? 89.99999, right? Okay, good. All right, so those are acute angles. AOC. Okay, AOC, another easy one because it starts at A. So AOC looks like a 65-degree angle. So again, 65-degree angle, that would be another acute angle. BOC, so now we're starting at B. So I'm going to have to kind of do a little bit of subtraction, right? So this one right here is at the 65 mark. This one right here is at the 35 mark. So 65 minus 35 is going to leave me with a 30-degree angle. Again, a cute little angle. Haha. All right, and then BOE. So BOE. So we already have B is at 35. E is at, what, 155? So if I subtract there, it's going to be 120 degrees, right? Did I mess up? Oh, that is 145. Ugh, fail. So it's 110. You're right. So this is a 4. What do we call the angles once they get bigger than 90 degrees? Obtuse. I don't have a cool little saying for that one. So. Okay, that's obtuse. Hey, whoa. So stuck right between acute and obtuse, right at 90 degrees and 90 degrees only. Those are the ones we call right angles. And do you guys know what the last one is?
Straight.
Yeah, it's a straight angle. It's kind of like an oxymoron, right? It's a straight angle. It's kind of weird, but that's what it's called. Okay, let's just put a couple indicators on here so we know right is always a 90-degree angle. What does a straight angle need to be? 180, right? Because that's half of the circle, which is going to form the straight line like that. Okay, angle addition postulate. So the angle addition postulate is super duper duper similar. You need another duper? Super duper 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 duper. It's kind of weird to say. Similar to the segment addition postulate. With the segment addition postulate, it was the sum of the parts equals the whole, right? It's the same thing here with the angle addition postulate. The sum of the angle, so the two couple interior pieces of that angle should add up to be the whole angle. Shocker, right? It doesn't, I mean, it's pretty self-explanatory as far as the angle addition postulate goes. Angle bisector. What does that bisector word mean again?
Center.
Kind of. Cut in half, right? So bisector means it's cutting in half. We saw segment bisectors that cut the segments in half. Angle bisectors are going to be a ray that cuts the angle in half. Okay, it's going to be a ray that cuts the angle in half. All right, let's practice using this. So the big thing that you are going to be using is the idea that the sum of the parts equals the whole, okay? So on page 2, we are going to both name and practice, okay? So I don't know if you realized or if you paid very close attention to the names of the angles, okay? To the names of the angles, okay? But I want to look at number 1 with you, okay? So the names of the angles, they always need to have the vertex, right? The vertex is where the two lines meet to form the angle. They always need to have the vertex in the middle. So I'm naming 3 different angles here, okay? So two different ways you can name an angle. If I'm looking at this angle right here, I can name it one of two ways, okay? And I want to show you that. So this angle right here in red, you can name it one of two ways. You could either say angle, I don't know why my thing does that. So we could call it angle F. So you can name it based on the vertex if that vertex covers the complete angle. Or we can name it angle E. Why is it doing this to me? E, F, H. Or, so I guess you could really name it three different things. Or H, F, E. Okay, so that's really only three different ways to name the same angle. So that's really only naming one angle. So let's name the other ones. So these are going to be my other two angles. Unfortunately, you cannot name these angle F because that's not the complete angle. Okay, so my other two angles would be, and you can name them a couple different ways. You can name them either EFG or GFE. You just have to make sure that the vertex is in the middle. So I'll just say angle E, F, G, and then last but not least, what is happening? My iPad is going crazy. All right. And then the last one would be GFH. Okay, so those would be my three angles. Angle F, angle EFG, and angle GFH. Okay? All right, I'm going to let you guys go ahead and work on the rest of this worksheet. Okay? So we'll go over the 1.6 notes. They're really similar. Just throw some different vocab words in there. But I'll go ahead and let you work on the rest of this worksheet together with your groups. Rock and roll. Okay, guys, let's jump to 4. Okay, so 4. Remember the whole angle is the sum of the parts. So to find JKL here, I'm just adding up the parts. So 31 and 85 makes 116. For number 5, it tells me that RSU, so that's the whole angle, right? The RSU, the whole angle is 91. So if I take off this 69 part right here, okay, then I'm left with 22. So RST is 22 for number 5. Any questions on those? Okay, for number 6, we know that UWX is a vertical angle, meaning that it's 180 degrees. So I can add up the sum of the parts, the x plus 20 plus x, and set it equal to 180. And that's my equation that I set up over here. I solved down to get x equals 80. Remember, x equals 80 is not my answer. I got to plug it back in. So 80 plus 20 is 100. So what's that? I put VWV. Or maybe that's supposed to be a U. UWV is 100 degrees. VWX is 80 degrees. Any questions there? And I do want you to get in the habit of doing answers like this, depicting answers like this, making sure to put on the proper notation. Angle VWX equals 80. And obviously it could be XWV, okay? So you guys can have some differences like that in there. Okay, let's look at the bottom 3. So number 7 tells me to find those two angles. Remember, you always have to look for what is given to you. And if you look closely, hopefully most of you saw the 90 degree, the right angle marker. So I know that this whole angle is 90 degrees. So that means if I add together my two angle, what am I trying to say right now? Expressions. My two angle expressions. So if I add together my two angle expressions, they should equal 90. That's what you see here. That's what you see that I have written down here. I combine like terms. I solve down, I get x equals 3. Remember, in order to find those two angle measures, I have to now substitute it back in. I don't necessarily need to see all of this work, but this is good work to show, especially if you're on some kind of standardized test or something, just to be clear of what you are doing. So I plug it back in, I get BAD is 72, and angle DAC is 18. Any questions there? 8 is a problem that I pull. Most of these problems are problems that I'm pulling from the book. 8 is actually a little unclear Or maybe it's not. But it seems kind of silly that they would label DEG as 92 degrees like that and then ask you what DEG is. Did anybody think that 92 maybe was DEF? Is that what you thought?
Yeah, because if both of the 92 is a reflex angle.
Oh, you're right. Right. So if the whole thing is, or if each one of those was 92, it would have to be obtuse, right? Yeah, so I guess maybe that's what I was supposed to pick up on, and I didn't quite do that. I guess what I looked at was I looked back here, and you can see the angle or the arrows pointing into each particular angle. Was this pointing into, I don't know, maybe the whole thing was supposed to be 92. If the whole thing was supposed to be 92, it does say, and this is obviously an important word, right? That EG bisects. Maybe my pen will work. There we go. EG bisects. So bisects means cuts in half. So if I cut 92 in half, that would make this 46 and this 46, right? If that whole thing is 92. That's a good point. Why I didn't see that in the first place, who knows? Because my brain is old. Okay, let's look at number 9. All right, on number 9, it says QR bisects again, PQS. So that means if this is the angle bisector, the angles on either side of it should be congruent or equal. So that's where I set my 4x minus 10 equal to the negative 3x plus 130. I solve down to get x is 20. Again, I plug it back in to find PQR is 70, and RQS is also 70. Which would make sense, right? Really, if I was in a time crunch, once I found PQR was 70, I know automatically RQS has to be 70 because they're congruent. But it's always nice to kind of double and triple check your work by just plugging it back in, making sure it matches up. Okay, any questions here? So basically the only thing we learned was the sum of the angles equals the whole angle. The sum of the two interior pieces equals the whole angle, okay? Any questions before we move on? Can I get a comfort level how we feel here? 3, 2, 1, 0. Okay, good. Let's move on to 1. Okay, so 1.6 just adds some special names in there, okay? So we have to know what the special names mean. Okay, so we look at complementary angles. So complementary angles are two angles that add up to a sum of 90. Okay, so it tells you that down here. The two angles that add up to a sum of 90. And one thing you need to know about complementary angles is they don't have to be right next to each other. Okay, we'll see a special name for that down below. Okay, but they don't have to be right next to each other. So that angle A and B that it's showing us over to the right-hand side in the complementary angle section, those are complementary angles, right? Because 20 and 70 adds up to a 90-degree angle. So just because they're not touching doesn't mean they can't be complementary or supplementary angles. Okay, and then we move over to supplementary angles. Those are two angles that add up to 180 degrees. Okay, so these two angles add up to have to add up to a sum of 180 degrees. So complementary, supplementary. An easy way to remember that, C comes before S in the alphabet. So C is first, S is second, C is 90, S is 180. If you can't remember the difference between complementary and supplementary, you can kind of think about it that way. I don't know. Just maybe a little easy trick to remember that. Okay. Any questions on what complementary and supplementary angles are? Okay. Adjacent angles. Okay. So we have a picture of an example and a non-example. Okay. So adjacent angles are two angles that share a common vertex. So remember the vertex, or a common vertex and a common side. So remember the vertex is where the two lines are going to intersect that create the angles, and they do have to have a common vertex and a common side. So this over here is an example. This over here is a non-example, right? These are not adjacent angles because they don't share a common vertex and side. Okay, so we have a special name for adjacent angles that both make up a straight angle. So supplementary adjacent angles, right? Supplementary adjacent angles. So they're adjacent because they have the common vertex inside. And they're supplementary because you can see that they add up to 180 from this straight angle right here. We call those linear pairs. So if you're ever asked what a linear pair is, it's got to be a adjacent angle that adds up to 180. So therefore it's supplementary. Okay. Any questions on linear pairs? Okay. I'll be honest. Vocab is my least favorite part of geometry. It's the big difference between geometry and algebra. I mean, there are obviously a lot of differences, but there's way more vocab that you got to learn for geometry. Okay, so it's important that you guys kind of understand these and start. I mean, when you are talking through these examples together, it's important that you try to use the correct vocabulary. Okay, because that communication piece is huge, and the more you communicate with it verbally, write it down, different things like that, the more you are going to remember it. Okay, and then lastly we have vertical angles. Vertical angles mean, so it says two angles are vertical angles when their sides form two pairs of opposite rays. Okay, so their sides have to form two pairs of opposite rays. So like my opposite rays here would be, let me highlight. Okay, my opposite rays would be this one and this one. My second set of opposite rays would be this one and this one. Right, so they have to form two sets of opposite rays. That makes them adjacent, or excuse me, that makes them vertical angles. So 4 and 5 are vertical angles, 3 and 6 are vertical angles. Okay, so 4 and 5 are vertical angles, 3 and 6 are vertical angles. Do we have any questions on any of the vocab pieces? We good? Okay, let's practice a little bit with it. Okay. So on our last page here, let's go ahead and do all of them. Okay, so I'll give you time to work on this entire sheet. So you're doing all 9 of them together with your groups. We'll come back and go over them, and then you guys will be able to. Oh no, we have a. Well, no, we probably won't have time to do the practice team challenge thing, but that's okay. We'll probably just have time for preparation. So I'll give you a good 10, 12 minutes here to work, and then we'll rock and roll. Okay, let's look here. Okay, so 1 and 2 give me 2 adjectives each, right? Problems 1 and 2 give me 2 adjectives each. So number 1 gives me adjacent, meaning they share a side, and complementary, meaning they have to add up to 90. Okay, so I have to find the 2 angles that are side by side that add up to 90. That would be POT and SOT, or any variety of mixture of those letters. Just make sure the O's in the middle because that's the vertex, right? Okay, number 2 asks me for non-adjacent, so not touching, supplementary angles. And supplementary meaning they have to add up to 180, right? So I need to find 2 angles that add up to 180 that are not touching. Some of you started off by saying TOP and POQ, right? The problem with that is those are adjacent, right? So that wouldn't work. I would have to match TOP with this one over here, LJM. So LJM and TOP, or any, again, flip-flop variety of those would be the non-adjacent supplementary angles, okay? All right, for 3 and 4. 3 says A is a complement of B. That means those have to add up to what? 90. A is 36, so all I have to do is 90 minus 36 to get the measure of angle B equals 54 degrees, right? All right, supplementary is the same type of deal, except it would have to equal 180. So that one would be what, 63. So measure of angle C is 63. I'm not going to go over that. For sake of time, I set up the equations here, but I'm not going to solve them. We can see number 5, those are complementary angles because there is the right angle marker in there. So add those together equals 90. You should get x equals an answer and then plug them in to find your angle measures. Okay? For number 6, that's a vertical angle. So those are complementary, or excuse me, those are supplementary, meaning they add up to 180. So add them together, equal them to 180. Okay, let's look at 7. Okay, linear pairs that include 1. So remember, linear pair means supplementary, so it adds up to 180, and they're adjacent. So I see here 1, 2 is a linear pair, and 1, 4 is a linear pair. So I would say angle 1 and angle 2, and then also we have angle 1 and angle 4. See ya. Okay, identify vertical angles. Okay, vertical angles here. I'm not going to write them all down for sake of time. We have 1 and 3. We have 2 and 4. Do we have any on the bottom? We do, right? All 3 of them are actually vertical angle pairs. 5 and 8, so it's going to get kind of tricky to do this. 5 and 8, 10 and 7, 6 and 9. Those are all vertical angles, right? Because their 2 sides create 2 pairs of opposite rays. Okay? So 1.5 was a little bit more on the math side of actually calculating the angles, looking at bisectors, looking at sums and different things like that. 1.6 is a little bit more heavy on the vocab side, understanding what complement means versus supplement versus adjacent versus linear pair versus vertical angles. Okay, all those different vocab terms that I can't seem to keep straight on a Friday block 7 for some reason. Okay, so yeah.